My name is Russell Wolf, and I'm going to talk to you about building a multi-platform Kotlin library. So a few quick notes about myself. I'm an Android developer at a company called Intrepid up in Boston. We're part of Accenture, and we do all sorts of digital product design, which in practice means we build mobile and web apps. Also, one of the organizers behind Kotlin Office Hours, which is a monthly meetup in the Boston area. So come check us out if you're ever up there. And I'm quick little agenda. I'm going to talk through what code sharing looks like in Kotlin, specifically for mobile apps, and kind of what the architecture of that looks like. And then I'm going to walk you through an example of a library I've been building called Multiplatform Settings that uses all this stuff. So, starting off with code sharing, just a quick show of hands, who has done anything with multi-platform Kotlin, even if it's just kind of building demos, building samples? Okay, a couple of you. And how about with Kotlin native? Yeah, a couple more. Cool. So give some review to you, those guys, and some new stuff to the rest of you. This is what it looks like when we build apps today. I and my team with me built an Android app. The people next to us built an iOS app. We do a lot of talking to each other. We try to coordinate and make sure we're building this thing the same way, but there's a lot of duplication that happens. And it's not always easy to keep things in sync to make sure that we're sharing concepts and not kind of relearning the same lessons twice. It'd be much nicer to live in a world where we could have some sort of shared dependency where the bits of business logic and application architecture that make sense to share could be written just once while still having a native UI layer around all of it. And Kotlin turns out to be a pretty nice tool to do that. So we'll talk through kind of some of those, some of the reasons that's the case. So Kotlin native is a way to compile your Kotlin source code without a virtual machine, so without the JVM, via the LLVM compiler. And it lets you target a number of native platforms, including iOS, and interoperate with the native APIs for those platforms. In the same way that the JVM Kotlin that you're used to can interoperate with Java APIs. And there's Gradle plugins. I'm not going to go into too much detail on them, but there's actually two Gradle plugins because they're kind of changing it and putting in a new one to do that configuration for you in a way that feels fairly familiar to what you're used to in a JVM Gradle project. JVM Gradle project. And the big thing that we get from Kotlin native is Objective-C and Swift interop, which in actuality is Objective-C interop, and Objective-C knows how to talk to Swift. So there's a couple little things that can get lost in translation, such as generics, but overall, you can it's pretty powerful. You can write Kotlin code, looks a little bit like this. You might have a function, you might have a class defined in your Kotlin code, and Swift can see it. It'll generally have kind of some sort of prefix to the call based on whatever the framework name that you created. But you can call into your Kotlin code from your Swift. So just Kotlin native lets you run Kotlin on iOS, but that doesn't get you code sharing yet. What gets you that is multi-platform, which is a framework that JetBrains has been working on that essentially gives you this common code layer so that you can compile source code with a sort of subset of the standard library that can then be run on all the different platforms that Kotlin can run on. And the focus on it is to share not everything, but kind of your logic layer, the things that that aren't platform dependent, so that like the pieces that are unique to our app can be shared, but the things that make sense to be native can stay native. And there's also a mechanism for defining platform-specific implementation code so that when you need to call into platform-specific APIs from your common code, you're able to do so. And what that looks like is expect and actual declarations. So these basically let you define something in your common code, declare something in your common code with the implementation defined in your platform code. And the compiler essentially forces you to have a one-to-one correspondence so that each platform has a single implementation for each expect declaration. A little bit like having a dependency injection framework where the Kotlin compiler will force you to, we'll kind of make sure that that implementation is there and put it in place for you. And what that looks like is I might have in my common code this function defined with an expect declaration. And I use the actual keyword on Android and iOS, and I can give it two different implementations based on whatever I need for that platform. So with all of that there, this kind of simple picture that we started from ends up looking a little bit more complicated, but we can talk through this and kind of digest it. So the orange box in the center there is our common module, is kind of the shared code that's kind of our goal. We want to kind of put as much as we can in there so that we don't have to write it twice. To the left and right of that are where our actual declarations go. So on Android, that ends up producing the same sort of AR library artifact that you would get, that you're used to in general from building an Android library. And on iOS, you can expose your Kotlin native code as a framework, which is the iOS and Xcode dependency format, which you can then expose to your Xcode project and your iOS app. What's cool here is most of this is built with Gradle modules in the way that you're used to. And then just in the upper right there, the iOS box is where you have this kind of boundary where you move back to the native iOS tools to build your native iOS UI. But what about when we want to have dependencies that we can call from that common layer? So by default, you have the Kotlin standard library, so you can kind of write simple little bits of logic there. But you kind of, we need to sort of write more libraries so that there are other things that we can do. And so that's kind of what I want to focus on. And what that looks like is essentially a library ends up looking like another kind of layer underneath the application shared code layer with the same three parts. So in the center, you have a common module for your library. To the left and the right, you have the platform implementations of that common code. And again, on Android, it looks pretty much the same as you're used to. On iOS, you now get a new piece. Instead of building a framework, you're now building a klib, which is the Kotlin native library format. And the reason for that is that this blue box in the bottom right is not actually ever not being exposed to Xcode and to your native iOS code. It's being exposed to the Kotlin at the level above it, and so it no longer cares about being a native iOS dependency type. It just wants to be Kotlin. So we're going to focus on this library layer, and I'm going to talk through this library that I've been building called Multiplatform Settings. It's not a super original name. I might try to come up with something more clever at some point, but I haven't yet. So it's on GitHub. You can check it out there. And what it does is let you save simple key value data from your common code and persist that between app starts. Under the hood, it's wrapping shared preferences, which you're probably familiar with from Android, and a similar API called user defaults on iOS. And you may know that the droidCon app this year is written using Multiplatform Kotlin, so they're actually using this library. So you can actually see that it works, which is pretty cool. Thanks to Kevin over there for that. So I'll talk through a little bit of code and kind of show you how this thing is built. So the core of it, there's an interface called settings, defines a bunch of get methods, put methods, exactly what you sort of expect if you're used to the shared preferences API. It has an implementation called platform settings, which is implemented using a bunch of expect actual declarations. And the reason for that is I wanted both to be able to expose different platform implementations, but also have an interface that users of the library could mock out in their own unit tests, and we'll talk a little bit about that later. The platform settings class does not define its own constructor because we need to be able to pass that in from the platform layer. So we need to create a shared preferences object on Android or and its user defaults object on iOS, which can then be passed to the settings object. And the only reason for that is because in my particular case, like I needed to have this platform-specific dependency. If you're building your own thing, you may be able to get by with just instantiating it from your common code. To make this a little bit easier, I also added this factory class, so that the reason that this is hard is that Android needs a context. I built this factory API basically so I could pass in that context once and then create multiple settings objects if you want to, just from your common code. So now the actual creation is happening with the same API for each platform, so you can run it from your common code. So once you have that created, I have some get methods, and the lesson to take here is your implementations can be very thin. Like my get API essentially looks exactly the same as shared preferences, pass in a key, pass in a default value. You don't have, this early in this ecosystem, you don't have to necessarily do a lot. The value that you're creating by building a library here is by doing the Android and iOS binding and not necessarily by adding a whole lot new in terms of functionality. But one thing that you do have to pay some attention to is where these APIs differ. So iOS does not, the user defaults API on iOS does not have a concept of default value the way that Android does, and I still wanted to expose that in my library API. So I have to do a little bit of extra work to check if things exist and return the default value if so on iOS. So in addition to sets, you obviously want some sets, some put methods. Here I kind of hide some of the Android complexity. So I wasn't interested in the editor abstraction that shared preferences has in my common code. So I just kind of call that internally in my put methods. I also do a little bit of kind of sneaking under the hood work to account for the fact that the types that Android and iOS expose are actually slightly different. So shared preferences doesn't actually let you save doubles, and iOS does. So I thought I'd build a double API anyway on Android, which is just kind of calling into longs under the hood and converting that via bytes. So once you have those kind of platform APIs in place, you can start to do some other more powerful things from your common code that you just have to code once. So I have some delegates, so some functions that return read-write property objects, so you can use that nice spy syntax. Also some operator functions, so that you can get that nice bracket syntax when you're getting and setting things. And the lesson here is once you've kind of abstracted your platform APIs away, there's a lot of power that you can get from just building things once at the common Kotlin layer. So some general lessons. It's okay to be thin. It's okay to not add a lot of new functionality. The value here, again, is in having something that you can call from both platforms. But also, you do sometimes have to do some work to make sure that the API that you're exposing is the same. And sometimes that's actually pretty hard. So I've mostly just kind of exposed the simple, easy APIs thus far. I'd like to add some more. I'd like to add some listeners. I'd like to add some, see the whole set of all of your keys and stuff like that, other APIs like that. They're a little funkier because they actually look a little bit more different on the different platforms, and there's more kind of decisions that you have to make in terms of what you want the shared API to look like. So, in addition to the library itself, in the repository I also have a sample app. Generally a good idea when you're building a library anyway. I think it's especially important in this Kotlin multi-platform world because there's not a whole lot of code samples at the moment. And so I think it's really valuable if you want to build something like this to make sure you demonstrate its usage, demonstrate how things are configured, so people have more examples to learn from. So what my sample does It's basically just a simple list of one setting of each type and a UI to get and set them. So the idea is show how to use the library from the common code and build a normal UI at the platform level. So this is what it looks like when you run it. Just a simple bare bones API. At the top, you can select the different keys that you want to use. You can input a value, some buttons to do different operations, and a little output field. I'm not going to show you the actual platform code here because it's not any different than what you normally write to build this UI, which is the point. Underneath it, though, there's a common code layer. And for that, I defined this settings repository class, which just holds a list of these settings config objects that define what the different UI operations, like what each of those button clicks essentially means for each key. The API ended up being a little more convoluted than I like. I might do some refactors there. But the point is you can build an app, show that everything works, and you can give people an example of how to use your code. And then in the UI code, each of the apps just instantiates one of those objects and builds its UI and calls into the methods that it needs from there. So in addition to sample app, obviously we want to make sure everything is tested and that it works. Unit testing is of course always important, but again, a lot of this stuff is especially important when we're in this new ecosystem and we want to make sure that we can demonstrate that everything works as we expect on both platforms. So to help us with that, Kotlin has these Kotlin test annotations that you can use from your common code that look a lot like what you might be used to with JUnit. And yeah, you can write your tests in the common layer and run them on both platforms. So to design these tests in my instance, I had to do a little bit of thinking about how to use the shared preferences and user defaults APIs. So I did a couple iterations of that where initially I was building some custom mocks and I didn't really like how that felt because it was kind of testing the mock code more than it was testing the actual code. So I ended up opting for using Roboelectric on Android and using simulator tests on iOS, which lets you kind of run on something pretty close to the architecture that would actually be used in the app. And I also ended up writing some tests at the sample level in addition to the library level. Not really looking for full coverage there, but looking for demonstrating that it is possible to test application code that is using this settings library and be able to mock it out and things like that. So some sample code there. The test at the library level has these this before test is like your JUnit before annotation. The test annotation obviously is the same as the JUnit test annotation. So the unit test looks pretty similar to what you might be used to in the Android world. And similarly, we have asserts that should look pretty similar to what you're used to. And we still have the ability to do all of the multi-platform things that we were doing before. So we still need to create a settings object or a settings factory in a platform-specific way, and we can still use expecting actual declarations to do that. So I'll talk a little bit about test at the sample layer too. Here, this is why I wanted to make sure I had a settings interface in addition to the platform settings implementation, so that at the application level, it's possible to just mock it out entirely. So I did this manually because there's not really a good multi-platform Android and iOS mocking framework that exists right now. But my API was simple enough that you can just kind of build it by hand. So I have this mock settings object. I defined this stub so that I can use that as the implementation for every method. And then at the use site in my tests, I can just make an anonymous class, subclass it, override the functionality that I need for my test with the behavior that the test needs, and then test the actual application code. So that's testing. Once you have that, you want to start putting it out there. So you're used to, perhaps, if you're a library developer, publishing jar files and AR files, which is what the Common and the Android modules create. You can do the same thing with a klib. So you can create Maven dependencies using all of this stuff. And I actually in my sample app, opted to actually read the dependencies from Maven in order to demonstrate that, yes, this actually does work. So now we've seen kind of a whirlwind tour of what some of this stuff looks like. What are some of the difficulties that can come up if you want to build your own? So obviously this stuff is also very early. So multi-platform is like it's getting mature. Like JetBrains would tell you to start playing with it, but like they do reserve the right to make changes as they need to. And some things to be shifting underneath you, particularly around the memory model, which they're still doing some thinking about. And definitely one thing to keep in mind is the IDE support for all of this stuff is still a little bit work in progress. So if you're doing multi-platform JVM side stuff, it's fairly good if you're using IntelliJ. If you're doing native stuff without multi-platform, they're doing some work in CLine and in app code to make that all work. There's not really a good IDE solution at the moment for multi-platform Kotlin native. So what I've mostly been doing is using IntelliJ and just building things using the command line Gradle tools. The other thing to just keep in mind is this stuff is all new again. There's not a ton of production experience with it yet. I used to say no production experience here, but again, it is being used in the droidCon app, which is pretty cool. Like, we're starting to get there. There's not a lot yet, but it's moving. And then probably the biggest thing is there's this seam here where you need to be able to combine the Kotlin knowledge and the iOS knowledge, right? So when you're building the iOS side implementation of a Kotlin module, in general, like people in the Android world know Kotlin a lot better than people in the iOS world, right? So we need to kind of start as a community doing more outreach to our iOS developers, getting them interested in kind of helping us kind of bind all this stuff together, because they know these APIs that we need to call into, and we know the language that we want to write it in. I suspect this is going to look a lot like what Kotlin on JVM looked like for Android maybe 2 or 3 years ago, where some people were getting really excited by it, but you had to start getting buy-in from the rest of the community. But with that all in mind, I highly encourage you to jump into the space and build your own. So like it's still early, but it's kind of an exciting time to be part of this community. It's moving quickly. There's lots of people kind of starting to do some interesting things. But there's still a lot of low-hanging fruit out there. So it's a really neat way if you want to start making an open source contribution. That was kind of what inspired me to jump into it. It's this kind of like wide open field where you can actually like make a fairly significant mark early on in this ecosystem. So with that, thanks a lot. Happy to answer any questions that anyone has. You can also reach out to me on Twitter. I'm at Russ H. Wolf, and there's some links. I think the top there is my library. In the middle is a write-up that JetBrains has on how to do that multi-platform architecture for Android and iOS. And the bottom there is this demo project that pretty much anytime I've had a question about how to configure something, that's where I've gotten pointed to get the answer. So thanks a lot. And yeah, does anyone have any questions?
You talked about, from the iOS perspective, the fact that you seem to be moving into Objective-C. And then you talked about iOS knowledge. And iOS knowledge today, I think, is intrinsically linked to Swift. How do you resolve the fact that you've kind of got to be in both spaces?
Sure, yeah. So the question is, if Kotlin is kind of connecting to things at the Objective-C level, and iOS developers are mostly working at the Swift level, how do we kind of rectify that bridge? Is that right? So I think, again, you can still kind of leverage the iOS expertise there. So essentially what it means is, like, there's certain kind of Swift side constructs that you're not necessarily able to use. But most of the APIs that you want to work with that are kind of like the system level iOS stuff, those are still written in Objective-C anyway. So what you really need from the iOS side is understanding how those APIs work, like understanding what are the things that the platform can do, what are the kind of caveats and gotchas and like things to watch out for when you're using them. I mean, I haven't done a ton of kind of super complicated stuff to know all of the like weird little edge cases that you can get into. But I think you can, yeah, like I think what you need is much more what the APIs are and what they can do than worrying about the kind of language specifics. Anything else in the back there? Can you speak up a little bit? Yeah. Sure. Yeah. So questions around performance. So I haven't done really any profiling myself, so I can't really answer that in detail. What I've kind of heard from the Kotlin team is a lot of stuff is not optimized yet, so you can expect it to get better. I'll say I haven't noticed anything that feels like a problem to me performance-wise. And I'm not super worried about it because the way things are built is that each platform should be kind of interoperating with its own native layer in the usual way. So I like, there's some complications there, like the Kotlin native memory model is looking a little different than what it would probably look like if you were defining it natively from Swift. But like there's not like JNI kind of layer or something like that you're kind of like calling through to access native APIs. You're building whatever the native bytecode is, and so it should still look fairly natural to the platform. Anything else in the front there?
Is there a collection of different library out there?
Yes, there. Yeah, I should have put that in this list actually. Sorry. There is. I don't remember the link offhand, but there is a awesome Kotlin native repository that someone put together that has a list of some of them. Yeah, I mean, I can list a couple off the top of my head. So, I mean, obviously, there's this one that I've been talking about. There's a SQLite one that TouchLab has been putting together called canarch.db. JetBrains has a couple of things. So they have a Kotlin Next serialization library that they're building native stuff for. They have a HTTP client that they've been building. And KTOR, their like web framework, is going multi-platform. So there's stuff there. There's not a ton yet, but you can kind of do some searching and find it. Is that right? Yeah, so questions around memory management and kind of what you have to be aware of. Yeah. Yeah. So yeah, I mean, memory management is a little complicated. I honestly haven't dug a ton into it myself. Mostly what I focused on is kind of wrapping around APIs as simply as possible to kind of hopefully kind of leave most of that to the platform itself. So Kotlin Native does give you a bunch of tools around memory management to make sure that like you can define things kind of scoped where you want them to be. But that is one area that they've talked about kind of doing like that might be changing a little bit as things go. Yeah, so Kotlin Native is using a reference counter also, but like I'm not super well versed in kind of the details implementation wise of what that looks like and how that compares to what iOS is doing natively. Anything else? Cool. Well, thank you very much.